Okay, hi everybody, my name is Carly Niski. I am a senior ambassador from Constraint 2152, and welcome to Rope Runner Derby Day One. Woo. Okay, so today I'm going to start sharing my screen with you and we'll go through our presentation. Okay. All right, so what are we doing today? We'll be going over who engineers are and what they do, criteria and constraint, what that is, and then form and function, what that is and how it relates to criteria and constraint. And then we'll be doing our super awesome activity. Now, who are engineers? So simply, engineers are people who use creativity, math, science to solve problems. And there's many types of engineers. So there's like chemical engineers, electrical engineers, mechanical, civil, and industrial engineers. So we'll be looking into what engineers consider as they design solutions, the physics behind the speed of the rope runners, and how we can use that to design a faster rope runner. So by the end of today, we'll all be engineers. Now, what are some examples of things engineers do? You can go ahead and mute yourselves. Let's see. For example, we have rocket engineers who build rockets, rocket scientists. Engineers design and build cars, bridges. Like mechanical engineers design cars, build rockets, and then we have civil engineers who are building bridges and roadways and buildings. We have industrial engineers who help make the materials and process of how everything goes together. Electrical engineers who are with lights, solar energy, is something electrical engineers do. Chemical engineers, something really cool chemical engineers do is help keep our water clean and our air clean. So they work on those two processes.
Do certain types of engineers come up with vaccines for a lot of things? Like vaccines for the flu and the cold, or just sicknesses?
I believe so. That might be an additional I could see somebody having an engineering degree and another subject working to create a vaccine. You definitely have to use problem-solving skills in order to do so, but I'm not sure if that's exactly engineering. But you do use a lot of the same problem-solving skills and science and math. So it is definitely a STEM field. Okay. So criteria and constraints. Have any of you heard of these terms before? You can just shake your head no, thumbs up, thumbs down. Okay. So criteria is the requirements of the project as given by the client. So a lot of times engineers are making something that somebody else wants to use. So that would be the client. So the client's asking you to make something, and the criteria are the requirements of your project. The constraint is what limits you have due to outside circumstances in meeting the criteria. So this would be the constraints would be the time you have to do it, the amount of space that your project has to fit in. For example, so if you're told that you need to build a skyscraper, the criteria is that it must be 50 stories tall. That's what your client's asking you to do, so 50 stories tall skyscraper. And your constraint is that it must be within the given lot and that it has a specific date of completion. Okay, form and function. This is really closely related to criteria and constraint, but it's also different. So we have the form, for rope runners. So this is what we decide to shape the rope runner into, and this depends on the intended function of the rope runner. So we have function, which is what your rope runner wants to accomplish. And must be determined before you design the rope runner's form. So what do you want your rope runner to accomplish? Do you want it to have excellent balance, move very fast? Do you want it to look the best, be the prettiest? So the function that these different functions also meet the criteria as given by the client. So the client would be me, and my criteria is that it must reach the bottom of the rope. So it must start at the top of the rope and reach the bottom of the rope. The form is what we want it to look like. So this would be like what animal, object, or character you're making the rope runner into, and what materials you decide to use. So the form depends on the function and the criteria, and is limited by the constraints, such as the materials you have been given on hand and the deadline of your creation. Okay, so our activity today is parachutes. So all of the materials I gave you are to create one parachute. These are some examples. We have this glider over on the left. These are 2 parachutes that I made. And then we have this kind of like ballooning parachute on the right, kind of like the classic style. Okay, so our task today, we have Andromeda and Bellatrix. Andromeda is trying to get from the tallest point to the ground in a controlled descent. And Bellatrix is just falling from the tallest point to the ground. So, what you're doing today is you're making a parachute that will slow Andromeda's fall as compared to Bellatrix, using the materials given. Your criteria is that the object is a parachute and it must slow Andromeda's descent. And your constraint is that you may only use the materials you are given, and it must be created in the time I give you. Okay, so Bellatrix and Andromeda are the 2 figurines in your bag. So they're a dog or a cat or some variation of the 2. Awesome. Okay, so you can indicate whichever one you want to be A or B. And these are the criteria and constraints on this slide are all of your guidelines for your project. So otherwise, you can make your parachute however you want. Okay, do you have any questions? Oh, so the materials we're using is the stuff given in your bag. So you can use any of that except the figurines, because the figurines are going to go attached to your parachute. But you can use everything else to make a parachute, including the bag itself. And the only criteria is that the object, or the parachute, must slow Andromeda down. So some of the things to consider while you start building your construction. Oh, the additional material you can use to make your parachute are scissors. So if you have scissors on hand, feel free to grab a pair and use those.
Carly?
Yes.
Really quickly, you have a few questions. Somebody's asking, Audrey is asking which materials they're using.
Yes, to answer that.
You answered that? Okay, perfect. Thank you.
You're welcome. Okay, so I'm going to give you the next 20 minutes to make a parachute. You can, once you design it, you can test it out, change it up a bit. So you can try out different parachute materials. You can test out which one is better. And other than parachutes, is there any other way to slow Andromeda down? Raise hand. Sophia, go ahead and unmute yourself.
Could you show us the pictures of the parachutes again?
Yes.
Okay.
Let me go back to that. Yes, I'll keep. Thank you. I will keep these up for you to look at. So some of the other things that we consider is if the only requirement I had given was that that Andromeda had to be slower than Bellatrix, then like one of the options you could do is just make Bellatrix more air resistant. have more air resistance, and so that, oh sorry, have less air resistance, that she would fall more, which is technically a parachute. You could also, anyways. So what parachutes do is they increase the air resistance of the object, and this causes them to fall slower. Can you still see my the parachute on your screen? Okay.
I also have another question. Are we allowed to use like tape or like extra materials or not?
Yes, there should be some tape in your bag. It'll come in a really tiny roll. It'll be round like a piece of a straw. Do you see it? It's blue tape.
Yeah.
Okay, yeah. So that is a foot of tape, and you can use that when creating your parachute. Okay, so I was considering different ways to make Bellatrix fall faster as compared to Andromeda. And I was thinking maybe we could increase the weight of Bellatrix. But this may not necessarily work, because from previous experiments, just as a reference, if both objects are equally air resistant, then even though they may have different masses or different weights, they'll fall at similar speeds. Because when you're falling, how you change your speed is by increasing air resistance. So later we'll be able to relate this to our rope runners. Does anybody want to share the thought process behind the design that they chose as you're making it?
I'm using the paper clips to like keep the pipe cleaners in place. Then I'm sort of like trying to hook the pipe cleaners onto the piece of fabric. And then I'm gonna test it out to see if it will like land really softly.
Okay, very good. And remember, when you're testing out different parachutes, you can always change up your design. So if you're like, oh, this ended up not working, or didn't work how I wanted it to, you can always go back and change how you designed your parachute. When testing out your parachute, if you find that the area you're in doesn't have a tall enough spot to try it out, you can feel free to leave your recording, just like go to somewhere else, maybe if you have stairs or if you have like a stool or something to stand on, you can go and do that and then come back to your recording.
Are we allowed to use this paper?
Yes.
Okay.
Everything in the bag and even the bag itself you can use. Okay. Everybody has 10 minutes left. Okay, if you can, make sure you at least finish one of your designs so that you have time to test it out and improve upon it. One thing that engineers do is that once they have a design that meets the criteria and constraints that they're given, or the criteria that are given and the constraints that they have, they test it out to make sure it works first, and then they look at it and see, is there any way that I can make this better, so that they have a better product by the end. So feel free to go to like another part of the house if you need to, or if you have like stairs, or if you have like a stool that you can stand on, so that you can drop your parachute from the tallest point. And if you're not sure if it's working or not, you can take Bellatrix and drop Bellatrix at the same time that you drop Andromeda. There you go. So in dropping Bellatrix at the same time is really beneficial because part of my criteria that I'm giving you is that Andromeda has to be slower. And since Andromeda and Bellatrix are the same speed, you know that Andromeda is slower if Andromeda reaches the ground after Bellatrix reaches the ground. Okay, so we have 4 minutes left. Okay, how's everybody doing with time? if you are done, can you put in the chat that you're done or that you'll be able to be done in the next 2 or 3 minutes? Okay, we have one person who's done. There we go. Sophia, are you done? Can you type in chat if you're done? Okay, I'm going to give you 1 more minute.
Are we gonna show like to everybody what we created?
Yes. Are you all able to use gallery view?
Yes.
Okay.
If someone isn't sharing screen.
Good. Hey, Maddie, are you able to unmute and talk to us? You can also use the chat. Oh, okay, there you are. Okay, it is 4:36. So our time is up for making our parachutes. Awesome. Okay. So I am going to stop screen sharing so we can use gallery view. There we go. Okay, so number 1, we'll go around to each person, and I want you to tell me if you're able to make a parachute that works in this amount of time, and then what materials you used, and yeah, just how effective it was. Okay, so let's start. Top left corner of me is Audrey. Do you want to start, Audrey?
Sure. So my parachute just barely works. It doesn't fall like it falls a little bit slower, but just barely. And
As long as Bellatrix hits the ground first.
okay, which she does for me. I used like the mesh material for the top of the parachute, and I didn't get to finish this part. I was trying to make it more secure, like the pipe cleaner. I just used a lot of pipe cleaner, the cut, and the mesh.
Okay.
And a little bit of tape to make sure it stayed.
Okay, very good. Okay, next is Bella. What did you use and how well did it work?
Okay, so I used the bag that it came in, and I obviously had to use the cup. I used the paper clips to keep the pipe cleaners from falling out, and I didn't want to waste the tape because I thought I would need that. Then I took the end of the pipe cleaners and tied it around the handles. I put 2 on each side and I twisted it. So then that way it would just be a little more even because before it was kind of tilting. So I just twisted it and bent it so then that way it would sit up. And Yeah, and Andromeda, no, Bellatrix fell first. Yay!
Very nice. Okay, Sophia?
Mine did not work because I used the fabric and it was too light to hold the animal. But I did use the pipe cleaners and I did tape them to the cup, but I think they were too heavy.
Okay, so in this instance, we would need more surface area to increase our air resistance.
Yeah.
And to counteract the weight of the pipe cleaners.
Yeah.
Okay. Cool. Okay, so next we have Maddie.
So I used the Christmas stuff. Sorry, my dogs are fighting in the back. The wrapping paper Christmas stuff, tissue paper, and I used string to attach it to the cup thing. And I did knots for the cup, but they kept coming out of the holes that I made. So I used pipe cleaners and wrapped them around the knots so they wouldn't move.
Okay.
And mine worked. Yeah, so I was really happy because mine works.
Nice. Next we have Sophia.
Mine didn't work very well.
What materials did you use? How'd you make it?
I used the string and the cloth stuff, and I kind of tied them together and put them, and I poked holes into the cup, and then I put the strings in, tied them together, and then I kind of watched it fail.
Mm-hmm.
It didn't go very well.
Yes, I'm thinking of the reason why the mesh didn't work as well is because there's all these little holes inside of it, which allows the air to travel through it, and so it doesn't catch it as well. So it has less air resistance, where in this case, we want more air resistance, if that makes sense.
Oh, yeah, that makes more sense.
Yeah. So that's why where Maddie had the tissue paper and she cut it the same size as the mesh circle, it didn't have all the little holes in it, and so it had more air resistance because it had more surface area. And so it fell slower than the mesh.
Okay.
Okay. Very cool. I hope that was fun for you guys. I was like making things, so awesome. I'm glad you guys liked it. Okay. So I'm going to present my screen again. Okay, so now we're going to talk about forces. So forces as a constraint is not only something that you can control, which is why it's a constraint, not a criteria. And you have to consider some of these forces when we go into making rope runners tomorrow. So do you guys know what forces are, what different forces there are? Why don't you give me a few? You can guess, okay.
Do magnets count?
Yes, so magnetic fields are actually an invisible force because they're not something you can feel or see. So you have invisible forces and contact forces, and magnets are one of the invisible forces. And gravity would be another invisible force. Okay, does anybody have any examples of contact forces? It's really simple. You got this. You can type it in chat if you'd like, if you don't want to speak up. I'll give you some examples. I am pushing my mouse forward. That is the force. So we have a push is one force.
So then would pull be a force?
Yes, so then a pull would be a force as well. Okay. And then we also have, what about if the force between this mouse and the depth. Is there a force between that? Do you know what that is? Okay, well that is friction. Friction is the force that prevents stuff from sliding past each other, makes it harder to slide past each other. Okay, so in this image right here, I have a rope runner. What forces are happening right here? These can be invisible or contact forces. Remember, forces are just something that makes an object move or to stop movement. So is this rope runner moving?
No.
It's not moving, right? So then what is causing it to not move?
The thing at the top? I'm still kind of confused on how to explain it.
Well, if it's at rest, it has to be, the forces have to be balanced. So if you look here, what is stopping the rope runner from falling down to the center of the earth? Because gravity is always present. So if something's at rest, there has to be something counteracting gravity. So why is the rope runner not falling?
Maybe because there are two things on the same side, on different sides, and they both weigh the same, and it's not falling.
Yes, that's one of them. So the balance of the rope runner, the balancers are fighting equal force, pulling it down, sort of, which is why the rope runner doesn't tilt over. But we also have the legs that the rope runner is sitting on, which is kind of a push. So it's pushing up against the rope runner, which is stopping it from being pulled down by gravity. Does that make sense? Okay. So if we have a rope runner going down a rope, like in this bottom picture here, the above picture would still apply. We have the rope, which is pushing up on the rope runner and stopping it from falling down. But the rope isn't flat itself. So the rope runner still falls down to the bottom of the rope because gravity is still pulling on it. And the rope is not providing a force completely opposite to gravity. Does that make sense? Or should I show a picture? Yeah. Okay, so here we have this beautiful circle, and that is our rope runner. We have gravity, which is pulling it down like this, in this direction. And then we have this surface right here, which is pushing up on the rope runner in this direction, like that. And so then when it's coming down the rope, you have a rope runner, which is this wonderful thought again. And gravity is pulling down on it. Because the rope is not flat, it's pushing up in this direction on the rope runner, which is why the rope runner moves in this direction. Does that make sense? Awesome. So how can we decrease, so thinking about our parachutes, how can we decrease, well, I say decrease the effect of these forces in the sides, but what we're trying to do is make the rope runner faster. So in our parachute activities, we made Andromeda slower, correct? So how would we make our rope runner faster, like thinking the opposite of that? So whereas the parachute, we wanted to increase air resistance to stop it from falling, for a rope runner, we want it to fall faster. So how would we do that? What is the opposite of increasing air resistance? Shout it out, you got this. So what we're trying to do is decrease air resistance, so instead of increasing it. More weight and more holes so air can pass through. Yes. So you want more air to pass through it and not be stopped by the rope runner. So when you're creating your designs tomorrow, you want to consider some of these things, especially air resistance, because this is the main force that stops your rope runner from moving fast. Just like the parachute is the main thing stopping Andromeda from falling fast. Oh, and that would be the end of our slides for today. Do you guys have any questions? Okay.
Are we gonna make the rope runner like by ourselves, or are we gonna do it like as a group?
So we will, it's a little bit of both. So we will be doing, I will be giving you some time to work together as a large group. Okay, I'm gonna stop recording now.